Hello class, and welcome to our notes on scale drawings. Our standard today is 7.G.1. Solve problems involving scale drawings of geometric figures, including computing actual lengths and areas from a scale drawing and reproducing a scale drawing at a different scale. Now these notes are very challenging, so we're actually going to split them up into 2 days. You're really going to need to make sure you're paying attention and you're rewinding and re-watching any parts of the video that you don't understand. It's important that you take control of your learning. Let's go ahead and start first with our vocabulary for today. Scale drawing, a proportional 2D drawing of the object, meaning it's two-dimensional, it's flat, just a drawing, whereas a scale model is a proportional three-dimensional drawing of an object. So for example, you might see an architect will make a model of a building, which is like a little miniature version of the building, before actually building the building itself. So it's three-dimensional versus the drawing, which is two-dimensional. Scale gives the ratio that compares the measurements of the drawing or model over the actual measurements. Now, when you're setting this up as a fraction, the drawing or model is always the numerator. The actual is the denominator. If you're setting these up next to each other, the drawing or model goes first, the actual goes second. And I'll explain that more when we get to those. Last one is scale factor. A scale without units can only be used when the units are the same. This is very, very important. When you write this in your notes, make sure you highlight, a circle, star, whatever you need to do to remind yourself that when it asks for the scale factor, it means you have to change the units to make them the same, then you can get rid of them. Okay, let's go ahead and take a look at teacher example 1, pencils down. What is the actual distance between Cadillac and Detroit? So what I need to do is I need to look on the map and find Cadillac, which is right here, and Detroit, which is right over here. Next, I need to take my centimeter ruler and I need to measure Cadillac and Detroit. Notice I line up right here with Cadillac, bring it over here to Detroit, and I can see it's right at 3.5 centimeters. So I measure first, use a centimeter ruler to find the distance on the map between Cadillac and Detroit. The map distance is about 3.5 centimeters. Okay, now the next part is to set up my fractions to compare them. Notice right here, this is very important, they've given us a key. Notice also, remember the drawing goes over the actual. So here we have 1 centimeter for the drawing is 50 miles in reality. So that means these two cities are not 3.5 centimeters away in reality, they're just 3.5 centimeters away on the map. So we're going to set up two fractions and make a ratio. Okay. 1 centimeter over 50 miles is proportional to 3.5 centimeters over some mystery amount of miles. Now, as you know, I can cross multiply. 1 times d is simply d. 50 times 3.5, I've got that written right here. I need to multiply and I will get 175. So that means that on the map, these two cities are 3.5 centimeters apart. But their actual distance is 175 miles. Notice we have about here because we're not using exact numbers. There's a little bit of room for error. So what I want you to do is go ahead and try this on your own. What's the actual distance between Traverse City and Marquis? Okay, now I know you cannot see Traverse City. The word Traverse City is right here underneath the ruler, and Marquis is right at the top. I did put the ruler on there so that you could measure because I thought it might be a little difficult on your computer screen. So go ahead and follow the steps. Remember, you can always rewind and go back to teacher example 1 if you need to see those steps, but I did put the steps here to refresh your memory. Okay, welcome back. Hopefully that you were able to solve. Let's go ahead and check your answer. Starting with step 1, the first thing you need to do was measure, and you found that it was 3 centimeters. So we have 1 centimeter over 50 miles, which was our key, equals 3 centimeters over d miles, some distance. Now I need to cross multiply. 1 times d is d, and then I've got 3 times 50. 3 times 50, of course, is 150. So my answer here will be the distance between Traverse City and Marquis is about 150 miles. Hopefully you were able to do that. If you do have any trouble, make sure you go back to Teacher Example 1 and re-watch that portion. Teacher Example 2 pencils down. The liquid outer core of the Earth is 2,300 kilometers thick. A scale model of the layers of the Earth is a scale of 1 inch to 500 kilometers. How thick is the liquid outer core of the model? Okay, so again here I would need to take my ruler, which I've already done, and I need to measure. Now notice we're given the scale, so we're going to do that as our first fraction, 1 inch over 500 kilometers. And we're comparing that to the model. Now, notice I don't actually have to measure here because I've got my information up here. Some amount is the model over 2,300. Okay, so I've set up my fraction. Notice the model is what I don't know. So I set up my fraction and I need to cross multiply. 500 times x. It's going to be the same thing as 1 times 2,300. Okay, now notice I don't have x by itself, so I need to go back to the beginning of the year and think about my inverse operations. I want to undo this multiplication by dividing both sides by 500. Okay, when I do that division, notice this will be a little tricky, but I do find that 500 goes into 2,300 4 6/10 times. So my final answer is the liquid outer core of the model is 4 6/10 inches thick. So my correct answer here is B. So obviously my drawing here is not drawn to scale, as my model would be much larger. Okay, so again all I'm doing here is setting up my proportion, cross multiplying, and dividing. Remember, it's important that the model is always in the numerator, the actual is always in the denominator. If you can remember that, you'll do just fine. So why don't you go ahead and try this out. The mantle of the Earth is 2,900 kilometers thick. How thick is the mantle of the model? We don't even need the picture. All we care about is this information right here. The scale is still 1 inch equals 500 kilometers. So start with that. That's your first fraction. Go ahead and press play when you're ready to see the results. Okay, let's go ahead and take a look and see how you did. Your first fraction, you should have 1 over 500. Your second fraction, we don't know the model, so that's our x, that's our mystery number. And we know that the actual is 2,900 kilometers. Now I can cross multiply 500 times x equals 1 times 2,900. Okay, now I need to go ahead and get x by itself, so I'm going to undo this multiplication by dividing both sides by 500. And I come up with an answer of 5 8/10, because we know 5, if we divide these, we can get 5 into 29 5 times, 25 with 4 left over, 5 goes into 40 8 times. Now our final answer does need to include words. We need a complete answer. So the mantle of the Earth is 5 8/10 inches thick. Okay, we're going to go ahead and stop there for today. Go ahead and check over your answers. Make sure you understand how to find the model or the actual when you're given the scale factor. Remember, you're always setting up your fractions with model on top, actual on the bottom. Model in the numerator, actual in the denominator. Have a great day.